Okay, so what we're going to talk about is radicals and fractional exponents. So we have to know our law of our exponents, okay? But my question today is what happens if we have a fractional exponent, right? So what happens if, like, I ask you what 9 to the power of 1/2 is? So let's go ahead, let's use our calculator, right? And I'm going to say 9 to the power of 1/2, or 0.5. Ooh, that gives me 3. All right, let's try another one. What happens if I say 49 to the power of 1/2? Make a prediction, and let's check out that prediction. So 49 to the power of 1/2. It gave you, ooh, 7. Okay, let's do one more. Let's say 100 to the power of 1/2. Again, let's make a prediction of what we think it's going to be. Again, using these first two examples. So 100 to the power of 1/2 gives you 10. Beautiful. Okay, hopefully what you noticed is that the result is always the square root of the base. So the square root of 9 gave you 3. Square root of 49 gave you 7. Square root of 100 gave you 10, right? So, so the result was always the square root of the base. So if we use that knowledge, if I say 4 to the power of 1/2, what's the square root of 4? 2. Perfect. So let's just try that out. Let's make sure that that actually worked. Right? So we do get 2. Excellent. Okay. If I gave you, let's do another one. What about 64 to the power of 1/2? The square root of 64 is 8. So this answer should be 8. So 64 to the power of 1/2 gives you 8. Beautiful, right? So we kind of can confirm our answers. Now, if I give you this, so if I say 7 to the power of 1/2, I don't actually know what 7 is because it's this. It's just the. It's not a perfect square, but what I should know is that it should be the square root of 7. So let's try that out. So 7 to the power of 1/2 should be this number. But now let's try the square root of 7. Does it give me the same number? It does. So why does this kind of thing work, right? So if you think about it, let's think about it in kind of a conceptual way, right? So let's take a look at 16 to the power of 1/2. 16 is really made up of 4 times 4. So I'm using the same number twice. How many numbers do I actually want? I want 1, right? And so I can kind of think of it as just 4, right? Let's see if that same logic works with a different fraction, right? So say I say 8 to the power of 1/3. This means that I want the same number to repeat 3 times. So I know that 8 is made up of 2 times 2 times 2. And how many 2's do I want? I actually just want 1. So this answer should just be 2. Let's test it out. 8 to the power of 1 divided by 3, which just gives you 2. All right, let's try one more like that. So what about 125 to the power of 1/3? So this is almost like saying we're taking the cubed root, right? So this would be the same thing as saying the cubed root of 8, right? It's the same thing. So again, 25, that's made up of 5 times 5 times 5, so same number 3 times, and then we want just one of them, so this answer should just be 5. So 125 to the power of 1/3 gives you 5. All right, let's go a little bit harder. What happens if I say 27 to the power of 2/3? So this time I want the same number 3 times. So that'll be 3 times 3 times 3. But this time I want 2 of the numbers. So I want these 2 numbers. So 3 times 3. So this number should be 9. Let's test it out on our calculator. So 27 to the power of 2/3 does in fact give you 9. All right. What about, let's try out a couple other ones. Okay. So using the same logic, what about this one? 25 to the power of 3/2. We want the same number to repeat twice, so 5 times 5, but how many numbers do we actually want? We want 3. How many 5s do I see? Just 2. So I actually need to add in another 5. So this will be 5 times 5 times 5. So by this logic, this should be 125. Let's test it out. 25 to the power of 3 halves. Gives you 125. Excellent. Right? Now we could break this 25 up. So this could be really 25. Let me write this a little bit better. 25 to the power of 1/2. And then raise that to the power of 3. Because again, when we raise the power to a power, we multiply 1/2 times 3. Gives us 3 halves. So we already know that this is asking us for the square root. So this is really saying 5 and then 3 times. Okay? So we're using this same the same logic in order to simplify, and it will always work out. Okay, so how can I kind of just rewrite these fractional exponents into radicals, right? So we're going to call this the exponent law for rational exponents. Okay, so I want to prove this information. I want to prove that the radical of 3 is the same thing as 3 to the power of 1/2. And I don't want to use a calculator, right? So what do I know? Well, I'm going to find out what the exponent is. So I'm going to say root 3 is equal to 3 to the power of x. I'm going to prove that x is going to equal 1/2. That's what I'm going to prove. Okay, so how am I going to prove that? Well, first thing I need to do is I need to get rid of this radical. So I'm going to go ahead, I'm going to square both sides. Square both sides. Square and a square root go away, leaving you with 3. And then raise the power to a power, we multiply. And then 3 to the power of 2x. Same base, so this exponent is just a power of 1, so I get to kind of drop my bases. So 1 is equal to 2x. If I divide by 2, I'm going to get x is equal to 1/2. And that is exactly what I wanted, right? And it would work for anything. So if I say I want to prove this one. So if I say that the cubed root of 17 is equal to 17 to the power of 1/3, right? So again, let's prove this. So the first thing I'm going to do is I'm going to rewrite it as this 17, and then I pretend I don't know what my exponent is. So again, I'm trying to prove that x is equal to 1/3. So this time, I'm going to raise everything to the power of 3, and then this will give me 17, because these two will cancel each other off, leaving you with 17 to 3 to the power of x. Anything always has an exponent of 1, so I drop my bases, focus on my exponents, divide by 3, and I get x is equal to 1/3. So essentially what's happening is that the number in our denominator becomes the index number of our radical. And then the numerator, right, is really the exponent, right? So we can kind of think of it this way. So if I have, so let's just say we have x, okay, and we're going to have some number right here, has to be larger than 2. And then we're being raised. So actually, instead of a number symbol, let's put like a letter. So we'll say A, and then B on the outside. This is the same thing as saying the radical of some number A with B on the inside. All of these are exactly the same, okay? And how you can write it as an exponent will be B over A, right? So whatever our index number is, it's always our denominator, and whatever our exponent is always our numerator of our fraction. All right, so let's go ahead and practice kind of rewriting these problems using this. So rewrite problems. So if I have the radical of 3 to the power of 4, right, the first thing I'm going to do is I'm going to rewrite this to make it 3 to the power 1/2. Raise that to the power of 4. right? And so this will be 3 to the power of 4 over 2, which ultimately is 3 squared, and would give us 9 if we were to continue further. Okay, so again, notice at the outside, the 4 on the outside is still going to become the numerator. What happens if I do this? Now 9 to the power of 7 halves. So again, how I can look at this, I can break it up into 2 parts. So I can take the square root of 9 and then raise that to the 7th power, right? So that's really 3 to the power of 7. That's one way to write it. Or I can say that this is the square root of 9 to the power of 7 altogether. Either one is perfectly fine. This one is a little bit more simplified than this one. Let's not worry about whatever 3 to the power of 7 is. We'll keep it exactly that number. What about the cubed root of 2 to the power of 5? So again, notice that the 5 now is on the inside instead of on the outside, like that problem. So it's like saying 2 to the power of 5, and we're going to raise it all to the power of 1/3. So multiply 5 by 1/3. This will give you 2 to the power of 5/3. So again, that 3 goes on the denominator, the 5 goes on the numerator. So again, as long as we remember the bases are the same, the index number of our radical is going to be our denominator, and then the exponent of either the entire radical or just of the number is going to be in your numerator. Okay, so let's try just a few more. Right, so how about you, oops, sorry about that. All right, so I'm going to put a couple problems up. Let's match them. So I'm going to say A is root x cubed. Let's say B is x squared over x power 5. C is the cubed root of x 5. D is 1 over x squared. E is that guy. F is just 1. G is x negative 3, x power 4. And H is x 1/4 squared. Match them. So match them with this. So here's 1, x power negative 2. It's just x for number 2. 3 is x to the power of 3 halves. 4 is x to the power 0. 5 is the square root of x. 6, 2/3. 7, 5/3. 8, x to the power negative 3. So go ahead, pause the video right now and match them up. All right, if you're coming back from unpaused video, right, so the cubed root of x to the power 3, so 3 needs to be in the numerator. This is a square root, so it is going to match with number 3. So we got that taken care of, right? If I subtract 2 minus 5, I am going to get negative 3, so that is going to match up with number 8, so that's taken care of, right? 5 is your exponent, 3 is your index number of your radical, so it's number 7. So that's taken care of, right? When we switch your 1 over x to the power of 2, D is going to match up with number 1 because it's knowing our negative exponents. So number 1 taken care of. 2 is our exponent, 3 is the radical number, so 2/3. So number 6 is going to be E. Bam. 1, that was a little trickier, but anything to the power of 0 is always equal to number 1. So this has to be number 4. And then when you multiply numbers with the same base, you add your exponent. So 4 plus negative 3 gives you just a 1. So G matches up with 2. And that leaves H. So this, the 2 is going to be, so this is going to leave you with x to the power 2/4, which is the same thing as x to the power 1/2, which is number 5. So that is your fractional exponents, radicals, changing it back and forth along with some of your old exponent rules.